All right, I'm going to discuss polynomials, what they are, how to write them in correct standard form, how to classify them, and then also how to simplify them by combining like terms. So with polynomials, and I'm looking right here on this part of the screen, and this is the sheet that you received today in class. Polynomials that have a degree of 0, they're just a constant. That would be just a single number. So if you just saw the number 5, that's a constant. Polynomials that have a degree of 1 are linear. Polynomials that have a degree of 2 are quadratic. If they have a degree of 3, they're cubic. If they have a degree of 4, they are quartic. And if they have a degree of 5, they are quintic. And in all honesty, we're only going to deal with up through the third. We're not going to do a whole lot of quartic or quintic. But just so that you're familiar with the terms. Then the terms, the number of terms determine whether it is a monomial, binomial, trinomial, or polynomial. So if it only has one term, it's a monomial. If it has 2 terms, it's a binomial. If it has 3 terms, it's a trinomial. And if it has 4 or more terms, it's a polynomial. So let's look at these examples, okay? So this first example, I'm going to highlight these are terms. This is a term, this is a term, and this is a term. Okay, so this has 3 terms, and because it has 3 terms, if I come back and I look at my little chart, it has 3 terms, so this is a trinomial. Okay, then when I look at it, I'm also going to look at the degree. And the degree is the power. So this has a degree of 4. This term has a degree of 4. This term has a degree of 3. And the reasons it does is because you have to add the degrees, the powers, to figure out the degree of the term. So because this is to the power of 2 and this is to the power of 1, this whole term is to the power of 3. And this is a constant, and constants are to the power of 0. So because of this, and because of the terms, this is a 4th degree trinomial. It's got 3 terms, so it's a trinomial, and it's a 4th degree because the highest degree is a 4. The highest term degree is a 4. So because of that, if I come back and I look here, I look at my table, it's a 4th degree, so that means it's quartic. Now, all polynomials, they need to be written in what's called standard form, and standard form just says that the degree of your terms are decreasing. So this is in correct standard form because this is the 4th degree, 3rd degree, and 0 degree. So they're decreasing, so this is correct standard form. If they all have the same term, the same degree, each term does, so like if you have negative 5a plus 4b minus 3c minus 2d plus 8. This is correct because they all have a degree of 1. So what we would do is we put the variables in alphabetical order. We put the terms so that the variables are in alphabetical order. Okay? So let's look at this next example here. When we look at the terms, this has 1 term. This has 2 term, and I highlighted the negative sign with it because the sign that's before the number goes with it, and if there isn't a sign, that means it's positive. Okay, so that's a separate term. This is a term, and this is a term. So there are 1, 2, 3, 4 terms. So because there are 4 terms, then this is a polynomial. And then I can look at the example and look and see what the highest degree term is. Well, this has a degree of 2, this has a degree of 5, this has a degree of 3 because this is like a 1, and then this has a degree of 0. So because the highest degree is a 5, I come back and look at my little table. This means that this is quintic, okay? Now, the problem with this particular problem is that it's not written in correct standard form. So we're going to rewrite it in correct standard form so that the highest degree of term is first, which is this one right here. So it's going to be negative 4a squared b cubed. And I like to scratch it out once I use it just to show that I'm done with it so I don't do anything else with it. The next highest term is this one, which is with the 3. So that's going to be plus 5a squared b. Scratch that out. Then the next one is this one, which is plus 3a squared. And then the last one here is plus 2. So this is correct standard form for this polynomial. Now, another term you need to be familiar with is leading term and leading coefficient. The leading term is when it's written in correct standard form. The beginning term, and I really should have gone around that plus sign. Let me fix that. Sorry, it's kind of messy. This is called the leading term because this is the first term. It's in correct standard form. The leading coefficient is the coefficient that's before the variable, okay? This is a variable. The number before the variable is the coefficient. So here, this is the coefficient of this term, this is the coefficient of this term, and this is a constant. When you just have a number by itself, it's a constant. Okay? Now, the other thing that I want to discuss is how to combine like terms. So we have this polynomial here, but it's not simplified. It's not written as concisely as it could be. Now, there's a lot of ways you can do this. You could go through and rewrite all your like terms together. I like to color code just because it kind of helps me, or underline. You can do whichever method works for you, but you just need to make sure you come up with a system that helps you keep track of every number, because you have to use all of them, and that you once you're done, you know that you've used it. Okay, so these have a like term of x squared. So these are my like terms, and I'm going to go ahead and highlight the sign that's before the number just so I know that the sign goes with the number. This does not have a like term because it has to be to the same power and it has to have the same variables. So that's going to have different like terms. So I'm going to go ahead and highlight this and highlight this, because those in green, those are like terms. And then I'll just use blue to underline this and to underline that. Okay, so when I write this in like terms, I'm going to start with my higher power just so that I know my answer is in correct standard form. So I've got 2x squared plus 4x. So that's going to plus 4x squared. So that's going to be 6x squared. Then I have minus 3x. It doesn't cross out well. And then minus 5x. So that's going to be negative 8x, or minus 8x. And then minus 8 plus 2 is the same thing as minus 6, because you have negative 8 plus 2 is negative 6. So it's going to be the minus 6. So this is in correct standard form. It has 3 terms. So it is a trinomial. It goes to the power of 2, so it's a quadratic. The leading term is 6x squared. The leading coefficient is 6. This term right here has a coefficient of negative 8, and this is a constant of negative 6. So those are just some of the key terms to point out in that problem. Here's another one, and the reason I wanted to give you this one is to point out this negative. You have to distribute the negative sign because of the parentheses. You have to distribute it to everything that's on the inside. So this is going to be 3x minus 2x squared minus 4x. And so now when I look at my like terms, I've got a 3x here and then a minus 4x here. So in simplified terms, this is negative 2x squared minus x. And you could have the 1x, but that's not correct. It's not as simplified as it could be. We would just write 1x, or write x without the 1. So 3x minus 4x, 3x minus 4x, that's the negative x right here, and then I have my negative 2x squared.